Welcome to Quality and Welding Metallurgy. I am Kalidas Sapata. Today we are discussing welding austenitic chromium-nickel stainless steel and piping and tubing. Introduction. The ideal piping system would be a single pieces of pipe. The form, shape, size and direction as to contain or convey the fluid required by the processing which is involved. For most systems, this cannot be changed in size, shape, direction. Operating condition usually preclude such fabrication. Joint become necessary. Piping system usually must be made of many different components, and the joint that cannot, they must be as strong, serviceable as the component themselves. Therefore, engineers and mechanics should be try to apply this joining method which most nearly meet the condition of one piece fabrication and also allow necessary assembly, erection, maintenance and operation. Most of austenitic stainless steel are readily weldable when the proper procedure and techniques are followed. They can be joined by most fusion welding process, and good pipe welder can adapt very quickly from the carbon steel or low alloy steel to stainless steel. Orbiting piping welding machines are also very adaptable to those materials. Reasonable care is required as in any pipe welding operation. However, careful adherence to the procedure requirement will usually produce excellent welding, piping and tubing. Composition, chemical composition range and type, number of those stainless steel generally available in root piping and tubing. These are American Iron and Steel Institute standard composition. Chemical composition range designation for 5 stainless steel generally available as cost pipes shown below. These are including because cast valve and fitting are considered part of the piping system. The weldability of casting may be somewhat less than that of root stainless steel of the same type. This is because fully austenitic casting have large grain than similar root material. Consequently, there is less grain boundary area along with the despair in impurities. As a result, there may be tendency lower hot cracking when welding some casting. However, proper control of composition of the casting to obtain 4 to 10% delta ferrite can prevent the cracking. Specification. Typically, American Society for Testing and Material (ASTM) specification covering piping and tubing in both cast and root are listed below. ASTM employs the AISI type number for designation, the austenitic type. However, the ASTM chemical composition requirement differ slightly from AISI requirement and will vary slightly in different ASTM specification. The composition range specified for cast tubing product are identical with those of the American Casting Institute. Specification for copper welding electrode and welding rod and electrode are provided. Base method. Primary type 304, 305, 309 and 3010. This material have any application and are widely used for their corrosion and oxidation resistance, high temperature strength and low temperature property. However, there are a number of welding related characteristics that may affect all of this. Type 304 and 305 may become sensitized by welding depending on their carbon content and the manner in which they are welding immunity to intergranular attack when exposed to certain corrosive environment. However, they still often are used in a weld condition, does not produce intergranular attack. The likelihood of corrosive attack on material sensitized by welding is not greater to higher chromium grade such as type 309, 3010. However, this time cannot be considered totally immune to intergranular attack when they are in a sensitized condition. Chromium-Nickel Molybdenum type 316 and 370. The addition to molybdenum to the chromium-nickel alloy does not alter their welding characteristics in any significant way. However, the weld themselves may display slightly greater susceptibility to intergranular corrosion in sensitized heat-affected zone than type 304 nitric acid service. Molybdenum reduces the resistance of stainless steel to corrosion by nitric acid. Stabilized type 321 and 347, titanium, chromium, Cv and titanium are carbide stabilized elements. During the steel making process, they combine with carbon before chromium does. Thus, subsequent welding, the formation of chromium carbide is minimized. When chromium carbide forms, the adjacent metal is adapted to chromium, thus reducing the material corrosion resistance. However, during welding, a very narrow zone immediately adjacent to the fusion line in the heat affected zone of the weld is heated to temperature high enough to dissolve almost of titanium, chromium and tantalum carbide. If the weld joint is subsequently heated to temperature in vicinity of 1200 Fahrenheit, 650 degrees centigrade, chromium carbide will precipitate at the grain boundary. Then the conditions are set up for what is known knife line attack in corrosive environment. Knife line attack can be prevented by heating the welding joint to a temperature in the vicinity of 1600 Fahrenheit to 807 degree centigrade. At the temperature, titanium, chromium, and tantalum carbide, since their solubility temperature is lower than temperature that of chromium carbide. This is called stabilized heat treatment, since it does not impair the corrosion resistance of the steel. Type, type 321 is stabilized with titanium, while type 347 is stabilized with chromium and tantalum. Type 321 display a greater susceptibility to knife line attack than type 347 because of the lower solution temperature of titanium carbide compared with chromium tantalum carbide. Low carbon type. Low carbon type 304L, 399S, 310S and 316L. This type are low carbon modification of the corresponding or primary grade in type 304L, 316 and extra low carbon content 0.03% maximum. Minimize the precipitation of chromium carbide both during welding and sensitization post-weld heat treatment. This term preserves the corrosion resistance of the weldment. Similarly, type 309S at 3010 with 0.08% maximum carbon reduce the likelihood of corrosion in comparison with their higher carbon counterpart. H type 304A, 316A, 321A, 347A, 348H contribute the high temperature strength of austenitic stainless steel. This precludes the application of austenitic stainless steel, chromium-nickel steel having extra low carbon content in high temperature service, where strength is an important consideration. 5 steel are identified with 8 suffix for use at high temperature. In this steel, the carbon content must be held within specified range, like 0.04 to 0.10%, rather than being held at below a maximum carbon level. Type of chromium-nickel stainless steel available in pipe and tubing. Type of chromium-nickel stainless steel casting is HD in specification, applicable to austenitic stainless steel piping and tubing component. Chemical composition requirement for weld metal for corrosion resistant steel covered welding electrode. Thank you.